So good evening, all of you.
Good evening, sir.
One minute till start class. So yesterday, what did we start? Alkyl halides, aryl halides, right?
Yes, sir.
Okay. So today it should be alcohols, phenols, ethers, right? Okay. So let us start today's class. Alcohols, phenols, ethers. Okay. Okay. Now alcohols in the first compound. Now can you see alcohols, phenols, ethers? Okay. Now in that alcohols, general representation as you can here you can see ROH, right? ROH, right? Now R may be alkyl group or aryl group. If R is alkyl group, if R is alkyl group, then it is called alcohol, right? If R is aryl group, then it is called phenol. But in both the compounds, you will have OH group. And what is Iupac nomenclature of alcohols? Here you can see alcohols are actually termed as alkanols. What are they? Alkanols. Okay. Just 1 minute. Yeah. Now, when it comes to alkanols, how will give Iupac names? First one is methanol, because here it is a methyl group. That means only one carbon. One carbon root word meth. There is no double bond. So, ane. Functional group OH is ol, methanol. Second one, 1, 2, 3, 4. 4 carbons are there. 4 carbons means bute plus ane plus ol. But OH group is presented here, first carbon. Next, ethane 1,2-diol. How many carbons? 1, 2. And 2 H groups are attached at first carbon and second carbon. So it is diol. And whole group is present at first and second carbon. This is propane 1,3-diol. Done. Next, preparation of alcohols. Let us see preparation of alcohols. Can you see preparation of alcohols? Yeah. This is the preparation of alcohols. The first method, oxymercuration, demercuration. In oxymercuration, demercuration, you can see here, alkenes can be converted into alcohols. So oxymercuration, demercuration is that agent is mercuric acetate. Mercuric acetate. So it follows, this is key point, sir. Follows Markovnikov's rule. So Markovnikov's rule, the OH, negative part of the reagent. Here you can see CH double bond CH2. You can see here CH double bond. So here you can see CH double bond CH2, right? So this is CH double bond CH2. Then where which carbon will be attached with the OH minus and H plus here. Now, according to Markovnikov's rule, negative part of the reagent is attached to the carbon having less number of hydrogens, So this is the carbon where the OH minus will attach because this carbon is having less number of hydrogens. Okay, so that is why OH group is attached here. This carbon having lesser number of hydrogens, right? So next, hydroboration oxidation. What is the next method? Done, sir. Then hydroboration oxidation. Here, this is a key point, sir. Which is key point here. Anti-Markovnikov's rule. It follows anti-Markovnikov's rule, right? So according to anti-Markovnikov's rule, the negative part of the reagent will be attached to the carbon having more number of hydrogens, How? This is C double bond C. Now, which carbon is having more number of hydrogens? That carbon will be attached with the negative part of the reagent. That means this carbon. This carbon is having more number of hydrogens. So OH will be attached here. Carbon having more number of hydrogens. So in this way, you can remember easily. Sir. Next, from Grignard reagent. What is it? From Grignard reagent, RMGX. Always the role of RMGX is it gives here. Example you see here. Example here. It gives what it is giving. Grignard reagent always produces R minus. It produces always R minus. So that R minus will be attached to the carbon having positive charge, and O will get minus charge, and MgX will be attached to that O, right? So like this. Okay. Let us see here. Now R minus is attached to this carbon having a positive charge. Here this carbon gets positive charge, oxygen gets a negative charge, right? So finally hydrolysis, break this bond here. Here what is forming? OH bond. This is MgX-OH. So finally you are getting OH here. From hydrolysis of alkyl halides, direct nucleophilic substitution reaction. Nucleophilic substitution reaction. OH minus will substitute X minus. You are getting alcohol. Okay. Then reduction of carbonyl compounds. By reduction of carbonyl compounds. So reduction of carbonyl compounds. So CHO, carbonyl means aldehydes. So CHO group is reduced to CH2OH. This is the conversion by using strong reducing agent like lithium aluminum hydride or simple catalytic hydrogenation. In both the cases, CHO group is converted into CH2OH group. Then esters also, COR group is converted into CH2OH and R prime OH also. In industrial preparation of methanol, carbon monoxide plus hydrogen gas gives you methyl alcohol. So methyl alcohol has poisonous nature. It is poisonous in nature. So this is about next preparation of ethanol, ethyl alcohol. In that first one, acid hydrolysis of ethane. For ethene, CH2 double bond, CH2. Acid hydrolysis of ethene, right? That is in presence of mineral acid. Then you'll get simple ethyl alcohol. Then second method, fermentation method. What is fermentation? Breaking up big molecules into simple molecules. In the first one, molasses. So molasses contains sucrose. This is sucrose set. This is sucrose actually. This C12H22O11. This is sucrose. Now, when it interacts with invertase, an enzyme, it gives glucose and fructose. And glucose, by the interaction of gymase, it gives ethyl alcohol. That is our required product, right? So this is from molasses. This is from molasses. The next method from starch. What is the next method from starch? So how we can prepare from starch. Now this is starch. Starch, when it is interacted with the diastase enzyme, it gives maltose. Maltose on interaction with maltase enzymes. This is glucose. Then glucose on interaction with gymase gives ethyl alcohol. Now the obtained 10 to 12% ethyl alcohol obtained is wash or wort. What it is called? Wash or wort. Okay. And what is rectified spirits? Rectified spirits is obtained by distillation of wash. Then you'll get 95% pure alcohol. Then again rectified spirit on fractional distillation, you get 99% alcohol. That is what we call absolute alcohol. Then what about physical properties? What about physical properties, right? So already we discussed boiling point is directly proportional to molecular weight, and boiling point is inversely proportional to number of branches. Number of branches. Done, sir. So next part will be chemical properties. So let us move to chemical properties. So first one, reaction with metals. First one is reaction with metals. So there you can see when alcohols reacts with metals. So like active metal like sodium. Active metal like sodium. Then what you will get, sir? So liberation of hydrogen gas. What you will get there? Liberation of hydrogen gas. So liberation of hydrogen gas indicates acidic nature of alcohol. Acidic nature of alcohol, right? So this reaction, it is an example or evidence for acidic nature of alcohol. It is an evidence for acidic nature of alcohols. Then esterification. RCOH, ROH, carboxylic acids and alcohols combine together to form ester. Then when alcohols are treated with concentrated HCl and zinc chloride, this already we discussed yesterday, low-Cas reagent. Then nucleophilic substitution. OH minus will be substituted by Cl minus. Then you get alkyl chloride. Then we'll proceed with the next properties. with thionyl chloride. Next properties. With thionyl chloride. Yes, with SOCl2. ROH plus SOCl2. Already we have seen these reactions in alkyl halides or alkyl halides. You will get corresponding thionyl chloride, alkyl chloride, sir. Then acid catalyzed dehydration of alcohols. Dehydration of alcohols. Elimination of water. This is OH minus, and from this hydrogen. What you will get? CH2 double bond, CH2. Then oxidation of alcohols. CH2OH group is converted to COOH group. Here you can see CH2OH group, this group is converted into COOH group, right? So this is oxidation of alcohols. Then next is important, sir. Very important. Haloform reaction. See, the condition is for haloform reaction, this is. So here you can see, this is the condition for haloform. Any compound which have RCOH group, that gives a haloform, that is CH3CO. What it should have? CH3, here you can see CH3CO. So that bond should be there, CH3CO. That gives you haloform, that is CHX3. Okay, sir. And the activity of alcohols with low-cost reagent. Yesterday we have seen tertiary alcohols are more reactive than secondary alcohols than primary alcohols. It's about reactivity of alcohols. Then Victor-Mayer test. What is it, sir? Victor-Mayer test. That is, now we are discussing distinguishing of alcohols. See, alcohols is there when they treated concentrated HI, followed by red phosphorus, and finally silver nitride. Then primary alcohols gives blood red colors. That indicates primary alcohols. Then if you get blue color, that indicates secondary. If you don't any color, then that indicates tertiary alcohol. So these colors you will get if alcohol is treated with concentrated HI, red phosphorus, silver nitride. Okay. So next topic is ethers. Next topic is ethers. So ethers general formula CnH2n plus 2O. General representation ROR. What is general representation, sir? ROR. Done. Next, Iupac nomenclature. So ethers are called Alkoxy Alkenes. What are they, sir? Alkoxy Alkenes. Okay. Now Alkoxy Alkenes. Here, CH3O, CH3 methoxymethane. CH3O, C2H5. This alkoxy group, here you can see. Alkoxy group is lower alkyl group. In this example, which one is lower alkyl group? Methyl, this is ethyl. Now between ethyl and methyl, which one is lower alkyl group? Methyl group is lower alkyl group. So it will be methoxy. What will be its name? Methoxy. Higher alkyl group ends with alkane. That is ethane. So methoxy ethane. Okay. Next here in this example, here you can see CH3, CH2O, CH2, CH2, CH3. So what is higher alkyl group? Propyl. So higher alkyl group is alkane, propane. Lower alkyl group ethyl, ethoxy. So ethoxy propane. Ethoxy propane. So higher alkyl group ends with alkane. Lower alkyl group will become alkoxy. Then, sir, next, preparation of ethers. Preparation of ethers. That the first most important method, that is Williamson synthesis. What is it, sir? Williamson synthesis. So what is Williamson synthesis? When alkyl halide treated with sodium alkoxide. This is sodium alkoxide, sir. This is alkyl halide when treated with sodium alkoxide. Then you will get corresponding ether. Eliminate NaX. Then what is remaining? R here, OR here. So R, OR, either you are getting, sir. Similarly, from alcohols. Alcohols, when heated with rehydrating agent like sulfuric acid, then also you will get this is either. This is either, sir. Then from alkyl halides. When alkyl halides treated with dry silver oxide, then again you will get CS3CH2O, CS3, CH2. So for your understanding, this can be written like this. CH3, CH2, Cl. This dry silver oxide is Ag2O. Okay. Like this. Now AgCl, here also AgCl minus 2 AgCl. Then what is remaining? CH3, CH2 and O here and CH2, CH3. So we are getting ether. Then from Grignard reagent, CH3, CH2O, CH2, Cl. So CH3, MgCl, RMgX. Already I told you, always with RMgCl, you will get CH3 minus and Mg plus. Then this chlorine will be attached with magnesium. CH3 minus will attach this CH2. So you are getting CH2, CH3 here. SARBOR. Then physical properties. It is used as an anesthetic. They are colorless and volatile liquids. They are colorless and volatile liquids. Then chemical properties with chlorine. What is this? With chlorine. So what will happen with chlorine, sir? Okay, now here alpha halogenation, sir. What you will get? Alpha halogenation. So here oxygen attached carbon. This is alpha and this is alpha prime. Both the alpha hydrogens are substituted by chlorines. So alpha prime dichloroether. Right. If it is in presence of sunlight, all chlorines, that means here 2 hydrogens, 3 hydrogens. Here 2 hydrogens, 3 hydrogens. All are substituted by chlorine atom. So CCl3, CCl2O, CCl2, CCl3. Or simply what we can write C2Cl5O, C2Cl5. Perchloroether. What is it, sir? perchloroether. Done, sir. So this is about chemical properties. Done. Okay. So let us G-cell method. So G-cell method is used for estimation of alkyl groups. Okay, this is used for estimation of alkyl groups. So that is cold concentrated HI and hot concentrated HI. Cold concentrated HI will get alkyl iodide plus alcohol also. But with hot concentrated HI will get only alkyl iodide. Only one product you will get. Similarly with VCl5, break these two bonds here. Break these two bonds here. Break these two bonds. Then add chlorine here, chlorine here. So 2 moles of ethyl chloride plus remaining POCl will get. Carbon monoxide. Carbon monoxide means always insert this carbon into the carbon chain. What it will become CH3CH2 COO, because if it comes here CO CH3CH2 COO, right? So then you will get ester. What you are getting here? Ester. With dilute H2SO4. So hydrolysis here, break it. Break this bond H plus here, OH minus here. Then what you are getting? The ethyl alcohol plus ethyl alcohol with A. With A. CH3CH2O in presence of light. Then you'll get peroxide linkage. What you are getting, sir? Peroxide linkage. Next BCl3. With BCl3 we'll get CH3, CH2O, CH2, CH3. CH3O, CH2. Okay. BCl3 will get break these two bonds here. Then break these two bonds here. This bond you break CH3CH2. This bond you break CH3CH2. Add chlorines. Then you get 3 moles of CH3CH2Cl. Cancel. Then with HCl, H plus is attached to this oxygen. And here means you will get oxonium salts. What you will get, sir? Oxonium salts. So this is oxonium salt. Similarly with CH3COCl. Where you break this Cl here. Here we will get CH3CO. CH3COO, CH2, CH3. Ester you will get, sir. Then test for ethers. So before anesthetic use, ether is treated with Fe plus 2 will give rise to Fe plus 3. Potassium isothiocyanide gives you red color. That indicates presence of peroxide. With starch and K, it gives blue color. That indicates presence of peroxide. Next, phenols. So there are different types of phenols. There you can see different types of phenols. Right? Here, phenol having methyl group, that is considered as cresol. Phenol, orthocresol, paracresol, metacresol. Then catechol, diol cell. So OH group is present at ortho, catechol, meta position, resorcinol, hydroquinone, para position. If three OH groups are adjacent, present on adjacent carbons, that is, it is called pyrogalol. What it is called, sir? Pyrogalol. Then preparation. First one is Dow's process. So when it is chlorobenzene, when treated NaOH followed by hydrolysis, then you will get phenol here. Then what you will get? Phenol here. Then the important point in this reaction, Dow's process, it follows through. This is key point, sir. Benzene mechanism. And nucleophilic substitution. Nucleophilic substitution means Cl minus here. Cl minus will be substituted by OH minus. Cl minus will be substituted by OH minus. Then dinitrochlorobenzene. So two electron withdrawing groups here. Two electron withdrawing groups are present here, right? So presence of two electron withdrawing groups makes nucleophilic substitution more easy. That is why here we are using only 150 degrees Celsius. So then Cl minus is easily substituted by OH minus. Cl minus is easily substituted by OH minus. Next, by steam distillation of disonium salts. Now this is disonium salt. Upon treatment with water, that means distillation, that N2 disonium group is substituted by OH minus. Similarly, distillation of phenolic acids, decarboxylation. What is that? Actually, decarboxylation, right? So this COOH, COO group. Okay, now decarboxylation. CO group is eliminated and ONA here followed by acid hydrolysis. Finally, you get OH. Similarly, from Grignard reagent. So this O will be inserted here. Okay. This oxygen molecule is inserted here. O. So that is why it is OO. Then with again one more phenyl magnesium bromide. Then you will get 2 moles of this. And these 2 moles, when treated with H plus, finally you are getting phenol. This method, you know, from fumine, you might have studied for PO. Isopropyl benzene, that is also known as fumine, will give you O2 on oxidation. On oxidation gives you, this is fumine. This compound, intermediate compound formed is fumine hydroperoxide. This is fumine hydroperoxide. Followed by hydrolysis will give you Phenol plus ketonic compound acetone. Ketonic compound acetone. The next, chemical properties. The first one, acidic nature of phenol. So phenol, when treated with sodium, you get sodium phenoxide. Sodium phenoxide. See this. Sodium. And it is able to produce hydrogen gas. So if it is able to produce hydrogen gas, please, when treated with sodium metal, that indicates again acidic nature of phenol. But why phenol is more acidic than alcohol? There you can see last two steps. Phenoxide ion is formed. Which one is formed, sir? Phenoxide ion is formed, which leads to more stable phenoxide ion than ethoxide. So as it is more stable, it is more acidic in nature. And phenol acetylation. Acetylation is with acetylating agent. Then you have to get OCOCH3. Next, this is very important. Freeze rearrangement. What is it, sir? Freeze rearrangement. OH on acetylation use. This H plus will be removed, and that in place of H plus you will get CH3CO group. So then the COCH3 group rearranges to ortho and para positions. Ortho and para positions. So COCH3 at ortho, COCH3 at para position. Benzyl chloride, same cell. In place of this OH, O plus C2H5CO. Phenyl benzoate. What you will get? Phenyl benzoate. Next, phenol with zinc test. Reduction cell. Zinc will eliminate that oxygen, then you will get phenol. Sorry, benzene. Then with ammonia, OH minus is substituted by NH2 minus. OH minus is substituted by here. From ammonia, which one is generated? NH2. Then you're getting aniline, and with PCl5, OH will be substituted by Cl minus. Next with PCl3. 3 moles of phenol reacts with PCl3. 3 moles of alcohol or phenol requires 1 mole of PCl3. Whereas bromination, if you consider, with bromine water, you will get 2,4,6 tribromo phenol. With dilute bromine, that means bromine dissolved in carbon disulfide. That gives you ortho and para substituted products. Similarly, with dilute HNO3, you will get ortho and para substituted, but with concentrated, you will get second reaction. 2,4,6 tribromo trinitrotoluene. So that is also known as, sorry, phenol. In this case, it is phenol. So 2,4,6 trinitrophenol, it is also known as picric acid. Then sulfonic acid, nucleophilic substitution. So by using concentrated HSO4, the electrophile SO3H is substituted at ortho and para positions. Next, Kolb's electrolysis. What is Kolb's electrolysis? When phenol treated with carbon dioxide gas, so you will get salicylic acid. Hematemen means chloroform and NaOH. Then you will get salicylaldehyde. Gutterman's reaction. When phenol treated with histidine HCl or AlCl3NH2, you will get CHO group substituted at para position. Para position. Then test for phenol, Lieberman test. When phenol treated with concentrated H2SO4 and aqueous NaNO2, you will get red color. And that red color, when it is treated with NaOH, converts to blue color. Friedel-Crafts alkylation acylation, always at ortho and para positions. Ortho and para positions. So those reactions will not change. Okay, this is about alcohols, phenols, and ethers. Alcohols, phenols, and ethers. Right? Then aldehydes and ketones. There is more to aldehydes and ketones. So aldehydes and ketones, they are collectively called carbonyl compounds. They are collectively called carbonyl compounds. That is aldehydes and ketones. There they will have C double bond O. Then Iupac nomenclature. Aldehydes are called alkanol. Identify parent alkane. There you can see CH3CHO. There you can see. This is CH3CH. How many carbons? 2 carbons. 2 carbons means ethane. Now you remove this E and introduce Al, then it will become ethanol. Here also is CHO, only 1 carbon. 1 carbon means methanol, methane, parent alkene is methane. Remove E and add Al, that will become methanol. Next, ketones. Ketones are termed as alkanones. So propanone. This is the 1, 2, 3. How many carbons are there? 1, 2, 3. 3 carbons are there. 3 carbons means propane. Propane. Just remove E and add O. It becomes propanone. Right? What is structure of these compounds? Both the compounds, aldehydes or ketones, carbon is attached with sp2 hybridized carbon. So what is the shape? Trigonal planar. Then preparation. First one is hydration of alkynes. Hydration of alkynes first gives vinyl alcohol and then finally aldehyde. Unsymmetrical alkynes will give you ketones. Symmetrical alkynes will give you aldehydes. Unsymmetrical ketones will give you ketone. Will give you ketone. Next, hydroboration of alkynes. So C triple bond CH, then you will get corresponding terminal CHO group. Terminal CHO group. Then, if non-terminal alkynes are there, then you will get corresponding ketones. Corresponding ketones. Next, ozonolysis of alkene. That is also will give you formaldehyde. There you can see final product is formaldehyde. These are all examples for ozonolysis. Reductive hydrolysis followed by reductive hydrolysis. Then dehydrogenation of alcohols. Primary alcohols on treatment with copper gives you aldehyde. Secondary alcohols on treatment with copper gives you ketone. Next, dry distillation of calcium salts of acids. CaHCO taken by Ca on distillation gives HCHO, or mixture of formic calcium formate and calcium carboxylate gives you RCHO. Similarly, for carboxylic acid, this is also reduction. COH will be reduced to CHO. Then with the manganese acid, MnO2 will get ketone. Then dehydrolysis of gem dihalides. What are gem dihalides? Halides attached to the same carbon. Halogens attached to the same carbon, they are called gem dihalides. Then Grignard reagent. By using Grignard reagent, it will undergo nucleophilic nucleophilic addition reaction. Nucleophilic addition reaction. What is that nucleophile in this case? Here. This is the nucleophile in this case. This R is coming as R minus. So that will act as a nucleophile. Let us triple bonded carbon. Then followed by hydrolysis, we'll get aldimine. What you're getting there, sir? Aldimine. Then aldimine finally hydrolysis will give you ketone. Sorry, here in this case aldehyde. Then from alkyl cyanide, RMGBr finally gives ketone, RCOR. Next, Rosenmund's reduction, very important. Acid chlorides in presence of palladium barium sulfate, that is what we call Lindlar's catalyst. So Lindlar's catalyst will give you corresponding aldehyde. That means COCl group. This group, COCl group is converted into CHO group by the use of Lindlar's catalyst. Stephen's reduction. This is nitride. C triple bond N. Nitrides on reduction gives you aldimine CH double bond NH followed by hydrolysis. Then only you will get aldehyde. Then by oxidation of methyl benzene, toluene. So toluene on oxidation, first treated with chlorine, then you will get in presence of sunlight, always you will get side chain halogenation, halogenation. Then you will get CH2Cl here, CH2Cl. Then again on halogenation, one more hydrogen is replaced, CHCl2. Then finally the CHCl2 on hydrolysis gives CHO. This is a chromyl chloride test. Next, acetylation of benzene. Benzene on acetylation gives you ketone. Chemical properties now. Aldehydes are more reactive because steric hindrance is less. Steric hindrance is less, so that nucleophile will add to the carbon having lesser number of hydrogens. Next, addition of Bisonium. What you will get, this you might have studied for PU. Cyanohydrin you will get. Similarly, addition of NaCO3. That SO3H group will be substituted. Addition of water. Hydrolysis. So finally you are getting the diol. Geminal diol you are getting with hydroxylamine. Hydroxylamine elimination of water takes place. So these reactions are easy to remember. Then with hydroxylamine, here you can see water is eliminated. Then remaining will be oxime. With hydroxylamine, you will get oxime. Then with hydrazine, phenyl hydrazine, always remember that. What do you have to remember? Elimination of water molecule. Then these are some important chemical properties. ketones. Now, catalytic hydrogenation. So we start from this. Catalytic hydrogenation. Aldehydes on catalytic hydrogenation, you get primary alcohol. Ketones will give you secondary alcohols. This is catalytic hydrogenation. But with lithium aluminum hydride, double bond, if CH1 double bond, both are present, then double bond is not affected by lithium aluminum hydride. But catalytic hydrogen will affect double bond also. So that double bond is also reduced. Next, Clementine reduction. So Clementine reduction, Wolff-Kishner reduction, they are all about, there you can see C double bond O groups are converted into CH2 groups. Here you can see the conversion. C double bond O groups, they are converted to C double bond O group is converted into CH2. Here also C double bond O, here also C double bond O. What happened? That is converted into CH2. CH2. Here also C double bond O group is converted here, this carbon. So is having hydrogen CH2. Now it is converted CH2. So whether it is Clementine reduction or Wolff-Kishner reduction, sir, you will get CH2 group, right? Cyanohydrin formation already we have seen. Phenyl hydrazine. Then with the hydroxylamine, Grignard reagent, done. So last reactions of aldehydes and ketones. With PCl5, C double bond O group. So you can see oxygen valence is 2. So 2 bonds are replaced with 2 chlorine atoms there. Here, this oxygen is replaced with 2 chlorine atoms. Okay, here also alpha halogenation. When it is treated with bromine, you will get this is alpha, this is also alpha. So one alpha hydrogen is replaced by the denser. And sweet reaction, very important. So this is hydrozoic acid, N3H. What is it? Hydrozoic acid. So hydrozoic acid gives alkyl cyanide. alkyl cyanide. Aldehydes. Ketones gives RCONHR group. RCONH group. Ketoenol tautomerism. This already we discussed regarding isomerization. Isomerism we discussed it, sir. Already we discussed during ketone transfer of proton from one atom to another atom. Transfer of proton from one atom to another atom. Okay. That is, again, I'm not going to discuss. That is ketoenol tautomerism, already we discussed. Then, aldol condensation. So, these are some frequently asking questions. So, very frequently they're asking, sir. Aldol condensation. So aldehydes are ketones having alpha hydrogen undergo condensation in presence of dilute alkali. In presence of dilute alkali. So here in step 1, the base abstracts the proton. There you can see the base. So here, this is the base. This base is abstracting proton. Then here this carbon is getting negative charge. So carbanion is generated. Carbanion. Now this carbanion will attack carbonyl carbon of another aldehyde. So we're getting O minus here. Followed by hydrolysis, O minus becomes OH. And upon heating, this H plus and OH minus. H plus and OH minus, they are eliminated, leaving a double bond formation. So what is eliminated? Crossed aldol means aldol condensation between two different aldehydes. Here, aldol condensation between two same. This is the acetaldehyde molecule. This is also acetaldehyde. Okay, crossed aldol. Different aldehydes. They are different aldehydes. Same mechanism, sir. Okay. Just 1 minute. So crossed aldol is between two different aldehydes. Then you will get total 4 products. Total how many products you will get? 4 products you will get. Okay. Same. Mechanism is same. There is no change. There is no change in it. Mechanism is same, sir. Okay. That you check it later. I'll send you that notes. Okay. So total 4 products you will get, sir. See here. Total 4 products you can find here. Last step here. CS3CHO, CS3CH2CHO on treatment with a base. So this is first product. This is second. This is third product. Then this is fourth product. Right? This is Canizaro's reaction. Aldehydes with no alpha hydrogen undergo self-oxidation and self-reduction. Aldol condensation, at least one alpha hydrogen should be there. But with Canizaro's, no alpha hydrogen should be there. So, 2 molecules. One formaldehyde molecule will undergo oxidation and one will undergo reduction. So, you'll get both oxidation product as well as reduction product. Understood? And Tishenko reaction. When aldehydes, acetaldehyde reacted with triethoxy aluminum, then you will get corresponding ester. In test for aldehydes, ketones and aldehydes, Toline's test, aldehydes gives silver mirror. Aldehydes gives silver mirror. And ketones do not give any test with this. What is Toline's reagent? Ammonical silver nitrate solution. It means silver nitrate dissolved in ammonium hydroxide. Silver nitrates dissolved in ammonium hydroxide. Done, sir. Next, failing solution. Aldehydes gives red colored precipitate. And Benedict solution. Aldehydes gives brick red precipitate. Failing solution gives red colored. Aldehydes, same aldehydes will give red colored, brick red colored precipitate with Benedict's solution. But aromatic aldehydes do not give failing tests. Then 2,4-DNP. 2,4-DNP is to identify both aldehydes as well as ketones. That means it gives characteristic reaction with carbonyl compounds. Then Schiff's test. Schiff's test means aldehyde restore pink color of Schiff's reagent. Pink color of Schiff's reagent. As usual, iodoform. Only one thing you need to remember, that is what is that? Any compound which is having this CH3CO group. What it is? CH3CO group. So that gives you corresponding haloform and carboxylic acid. So this is the condition with CH3CO. Carboxylic acids. So Iupac nomenclature, alkanoic acid. So HCOOH. How many carbons? Only one. Only one carbon means methane. So eliminate E and add oic acid. It will become methanoic acid. It will become methanoic acid. Then preparation methods. Let us move to preparation methods. So first one from methanol. So when methanol treated with carbon monoxide and a catalyst like rhodium iodide, you get corresponding carboxylic acid. An alcohol's on oxidation, CH2OH group, on oxidation with strong oxidizing agents like potassium dichromate, will give you RCOOH. Will give you RCOOH. Then oxidation of aldehydes. Already these are repeated reactions. And oxidation of cyanide. CN group is converted into COOH. Hydrolysis of ester. hydrolysis of ester, what will happen here? AH plus OH minus. What you will get, sir? CH3, COOH, and C2H5 OH. So you will get carboxylic acid. You get carboxylic acid. Next, oxidation of alkenes. Okay, terminal alkenes gives you carboxylic acid. Next one, on-Tystat reaction. On-Tystat reaction. So when acid chlorides are treated with diazomethane, CH2N2 is diazomethane, sir. So this is diazomethane. Then you will get RCOCHN2 followed by hydrolysis. You will get ketene. Again on hydrolysis, finally it gives COOH. And Baeyer-Villiger oxidation, RCOR ketone. When it is treated with peroxy acid, you will get corresponding carboxylic acid. Done, sir. Okay, next, chemical properties. What is it? Chemical properties. Let us see chemical properties. First one, esterification. So acetic acid on treatment with ethyl alcohol will give you ester. Thionyl chloride, OH minus, will be substituted by Cl minus. OH minus here. OH minus will be substituted by Cl minus. So you will get COCl here. With PCl5 same. OH minus is substituted by Cl minus. So you will getting RCOCl again. Then with PCl3, same cell. OH minus is substituted by here. So OH minus is substituted by Cl minus. So Cl minus will substitute. So you're getting COCl. So NH3 will abstract this proton, then you're getting RCOO minus NH4 plus. Amines. Amines also same cell. H will be abstracted by nitrogen, and finally you're getting a salt. So this is a salt, and this is also salt. With P2O5, these are all dehydrating agents. So that is why we are eliminating water, so that you are getting anhydride, RCOO, COR. This is anhydride. And decarboxylation. Decarboxylation means removal of CO2, COO minus group, right? So COO minus you remove, then R and H is remaining. You can see R and H. This R, this H. What you are getting? Alkane.
Daddy.
Okay. Next, alkyl lithium. So alkyl lithium, when carboxylic acid is treated, then you are getting the ketones. You are getting the ketones. So then reduction. Opposite to alcohols, sir. Alcohols on oxidation gives carboxylic acids. Similarly, carboxylic acids on reduction gives you alcohols. Next is very important, HVZ, Hell-Volhard-Zelinsky, alpha halogenation in presence of halogens and red phosphorus. Here that is the example. Which halogen? Here it is chlorine in presence of red phosphorus. Alpha, functional group adjacent carbon. This is alpha carbon. This is functional group. Adjacent carbon is alpha. So halogenation is taking place at alpha carbon. If you are using excess of chlorine, then you'll all hydrogens, all alpha hydrogens are substituted by halogens. 2,2,2 trichloroethanoic acid. Hunsdake reaction already we discussed in haloalkanes and haloarenes. Right? When silver salts of carboxylic acids, treated with the bromine, then you will get corresponding alkyl halides. Schmidt reaction. Previously we discussed, it gives primary amines. Hydrozoic acid, M3H means hydrozoic acid. And with diazomethane, it gives ester. It gives ester. And salts of carboxylic acid as soaps. So this, here you can see C15H31CONA, sodium palmitate. C17H35CONA, sodium stearate. So this stearate anion only will form micelles. That we discussed already in surface chemistry. Formation of micelles. Right? Amines we'll discuss tomorrow. After completion of amines, we'll go for functions. Right? So that we'll see tomorrow. And I'll send you these notes in group. If you want, you try to practice all those reactions. Right? So that's it for this session. Meet you tomorrow once again. Good night, all of you.